Hello everyone. So today we are going to talk about feature scaling in the Scikit-learn library. Specifically, we are dealing with the pre-processing module, and in this video we are going to see standardization. So the agenda for this video is prerequisites, introduction, standardization, an introduction about it, then scalars in Scikit-learn, documentation, and then we'll be seeing a sample code. So prerequisites. So Python, NumPy and Pandas is a prerequisite for almost all of our videos. And additionally in this, you should have some knowledge about statistics. So all these scalars and normalization, etc. So you are taught about these things in statistics. So having these details or knowing about them beforehand would be really helpful in understanding them. So next, introduction. So feature scaling is one of the most important steps during the pre-processing, and before applying any scaling transformation, it is important that we split our data into train and test set. So this is important because if we do not, then the whole point of the scaling is, it becomes invalid, because scaling before splitting, it results that the training and the test data is scaled around the mean, which isn't their individual mean value, which may or may not be near their individual mean value, and it goes past the whole reason why we're scaling in the first place. So what this basically means is, if we scale before we are splitting, so for example, if we get a mean value of the complete data set of, let's say, around 10 for one feature, and if, let's say, on splitting, the test data and the train data have different mean values, something like, let's say, the train data must be having, let's say, 6 and the test data might have 15. So if you scale before splitting, your whole data will be scaled around the original mean value that was 10. So it goes over the reason, and we are actually scaling so that individually both the data, the train and the test data, will be scaled around the mean. So the two most important scaling techniques are standardization and normalization. Now standardization. So standardization is also known as z-score normalization. And in this video, like I mentioned, we're going to see the standardization only. We'll talk about normalization in the next video. So standardization or z-score normalization, it transforms the feature by subtracting the mean from it and dividing it by the standard deviation. So it is also written as x new equals to x minus mean divided by the standard deviation. So it is pretty straightforward formula, and standardization is not affected by outliers, as there is no predefined range of transform features. So unlike normalization, in this there is no predefined range where you are going to standardize, let's say, between 0 to 10 or something like that. What standardization does is it rescales the data to have a mean of 0 and a standard deviation of 1, that is unit variance. So you cannot predefine a specific range in which you are standardizing a data. The range is not determined by us, so we just rescale it such that the mean becomes 0 and the standard deviation becomes 1. That's all. And standardization does not affect the shape of the distribution. So the shape of the distribution, as in the geometric shape, let's say if you're plotting it as a graph, like a bar graph. So if you're standardizing the features, the bar graph will still seem the same after standardization. So that means that it does not affect the shape of the distribution or the geometric shape. Now scalars in scikit-learn. So we have standard scalar, which we just saw, which is like z-score normalization, where the new variable is given by x minus the mean upon the standard deviation. So that is standard scalar. Then we have min max scalar, in which the x new is given by xi minus minimum of x, the complete feature, divided by maximum minus minimum of the complete feature. So as the name suggests, min max scalar. So you're going to use the minimum and the maximum value of that specific feature and get the new value based on that. Now max abs scalar. So again, as the name suggests, it will be taking the absolute of the maximum value. So it's directly xi dash or x new equals to xi upon absolute of maximum x. That means dividing the value of x by the maximum of that column, the absolute value. And we have robust scalar. So robust scalar, by default, it divides the it uses third and the first quartile range. So x new or x scale equals to xi minus x median divided by the third quartile minus first quartile. Now again, for this to know what quartile is, so this uses interquartile range, and to know what quartile is, you need to have certain knowledge of statistics. Now we cannot go deep into that, but you can also customize the robust scalar into changing the quartile range, or instead of 75 and 25 you can also make it as 80-20 or 70-30 and so on. So it is robust as the name suggests. So before moving on, we can actually see how these scalars are on a whiteboard. So here I've taken a sample data set where we have height and weight, and the mean and standard deviation is already calculated over here, so we need not calculate it again. Now to see an example as to how we will use these scalars. So for example, if we want to use the standard scalar, so over here, let's say I want to use standard scalar on the weight column. So for the first entry in the weight column, which is 85, so my new value will be something like 85 minus the mean. The mean of weights is 81 according to our table, and divided by standard deviation. So the standard deviation of weight is 7. So this gives us 4 upon 7. So that is approximately 0.57. So 85 will be written as 0.57 when we do standard scaling or z-score normalization. Now similarly you can calculate for 68, and for 68 we will get something like 68 minus 81 upon 7, so which will be minus 13 upon 7. So that gives us roughly minus 1.85. So instead of 68 you'll be writing minus 1.85. So that was about standard scalar. Now if you want to use min max scalar, you have to take the x value, you have to remove the minimum from it, and then divide it by the difference of the max and min. So first let's see what the maximum value in weight column is. So in the weight column, if you see, the max value is 85 and the min value is 68. So max minus min is basically 17 over here. Now for 85, let's say if you want to standardize 85 using the min max scalar, it will be 85 minus 68 divided by 17. So 85 minus 68 is basically 17, and this will give you 1. So 85 will be written as 1 if you're using min max scalar, and similarly 68. So for 68, 68 minus 68 is 0, so 68 will become 0. So min max scalar basically will give you values between 0 to 1, and again 85 over here will be 1. So let's see what it will be for 80. So for 80 we will have 80 minus 68 upon 17. So that gives us 12 upon 17, which will be approximately equal to 0.7. So we can write 0.7 for this, and 85 will again be 1. So that was about min max scalar. Now max app scalar. So for max app scalar, first the absolute of maximum. We have maximum as 85, absolute of 85 is again 85. So we directly divide the value divided by, and we divide the value with the maximum. So again 85 becomes 1 because 85 upon 85. 68 becomes 68 divided by 85, so that gives us 0.8. So 68 becomes 0.8. Similarly again 85 will become 1 and 80 will become around 0.9. So that was about max app scalar. Now for robust scalar, this won't be enough. We'll have to do calculation. We'll have to find the interquartile range. So I won't be showing that here. However, you can, if you're not sure what it is, you can just go through a few chapter of statistics. You can understand what interquartile range is. And also you can go through the official documentation of robust scalar and how to exactly use it. So yes, that was it, and let's go back to the presentation. Okay, so now we have to see the documentation. This is the official documentation of the Scikit-learn library, and inside it the pre-processing data module, I have opened it. Now we have already seen a lot of things from these, but now we'll be seeing standardization. So for standardization, like I mentioned, it is a common requirement for many machine learning estimators, and it's implemented in Scikit-learn library. So uh, it is a very important part of pre-processing, and it helps us with many models. So again, now they're talking about standard scalar and what it is. So they're showing an example as well. Similarly, they are using max app scalar over here, so scaling features to a range. So now you can also scale a feature to a range that is from 0 to 1. So that is max app scalar. We also saw an example on the whiteboard, and then there's coding example for it. Then they are also talking about the robust scalar. So there's also scaling versus whitening, the difference and all. So there's a lot of things over here, and of course you can go ahead and see it. So that was it from the documentation. I think we have coding next. Let's see on the presentation. Yes, so we'll go ahead and see a sample code for standardization and the different scalars in the Scikit-learn library. So we'll be using the same file which we have been using so far, and in this we'll continue at the end. So I'll just add a text, scalars, and we'll begin the coding. So firstly we'll import pandas as pd, and we'll import a data set, or we can also build one ourselves, a small one, but it is easier to import the data set. So we'll take the iris dataset and we'll store it in a variable. So now we'll convert it into a data frame and basically store it as a data frame using the pandas library. So df equals to pd dot data frame, and data equals to d dot data, the data stored in our variable d, and columns equals to d dot feature underscore names. So that should do it. Now we'll just check the first few rows of our data set. So it is connecting. Just put a print statement in case. Okay, till then I'll go ahead with the code. Now from sklearn.preprocessing we will import standard scaler. So first we'll be seeing the standard scaler, and like you can see we have imported the data set and you can see the first 5 rows. So this sepal length, sepal width, petal length and petal width. So we have seen this data set before many times, and here we are going to again use it, this time for scaling. So now for standard scaler we have imported it from the Scikit-learn.preprocessing module, and now we'll take a variable, let's say scaler equals to standard scaler. So that ought to do it, and we'll just print, let's say scaler dot fit transform, and we'll take our data frame and we'll just transform one specific column. We can take the first one, that is petal length, and so yes, dot values, we have to take dot values and we have to reshape it -1, 1. So let us see. So like you can see now we have used standard scaler and we have taken the petal length column and we have just scaled the data completely. So over here it's -1.34, so the first two entries are basically the same for petal length, yes, 1.4 and 1.4. And the formula for standard scaler, it was the xi minus the mean divided by the standard deviation. So the same formula is used for each and every entry and you get different values. So you can see the data is very scaled and it seems consistent. Now standard scaler, so yeah, that was about standard scaler. Now we can see the min max scaler. So hashtag min max scaler. So I just added a comment over here from sklearn.preprocessing import min max scaler. Yes. Now again we'll use the same variable scaler equals to min max scaler, and this time we'll take we can take feature range, and then we will do scaler dot fit underscore transform. So this time we'll take a different column. We can take sepal width. So again we have to do dot values dot reshape -1, 1, and yes, we'll print it of course. So like you can see that we have got our values, and you can see it's -1.5, -2.25. So what we are basically doing here is we are taking it in the range of -3 to 1, and we can also take it from 0 to 1. So when we take it from 0 to 1, you are getting all the values in the range 0 to 1. So over here for this you are defining the range and you're getting the values from 0 to 1. That means 0 will be for the minimum one and 1 will be for the maximum. So that is about min-max scalar, and you can customize the range as per your need. So earlier we saw it -3 and 3, and now we checked with 0 and 1 and it's different. So yes, now we can see what was the next. So yes, we have max app scalar. So from sklearn.preprocessing we'll import max apps scalar, and we'll use the same variable scalar equals to max abs scalar, and again the same code. So all these have basically just three lines of code. You have to take a variable, you have to initialize the scalar, and of course import the scalar before that, and then you have to fit transform it on the data set that you want to, or the feature that you want to. So now print statement and scalar dot fit underscore transform df, and this time we'll take another column, let's say sepal length. So dot values dot reshape -1, 1. So again this has given us all the values, and you can see there is 1 also, which means that this is the maximum value. So max app scalar, and next we have robust scalar. So from sklearn.preprocessing import robust scalar. Now let's take scalar equals to robust scalar, and we have to pass the parameter as quantile range. So quantile range. So like I mentioned, this scalar removes the median and then scales the data according to the quantile range. It defaults to the interquartile range, and that is between the first and the third quartile, which I showed in the formula, that was x75 minus x25, but we can also customize the range. So over here quantile range will be, let's say we can take 0.3 to 0.7 maybe, and then again we'll just print robust dot fit underscore transform df, let's say petal width dot value values dot reshape -1, 1. Okay, over here you have taken scalar. So it has scaled the data, and if we just remove the quantile range from here, it will scale it to the first and the third interquartile range. So yes, and again you can just customize it as per your own need. And that was about robust scalar. So let us go back to our presentation. So that's it actually from this video, and we'll see more into the scaling or normalization in the next video, and we'll see how normalization is different from standardization and how does Scikit-learn library support that. So thank you for watching. I'll see you in the next video.